Hey, programming fans. Well, we're still talking about the P5 sound library and some of the pieces inside it. And what I want to talk about in this video is the P5 audio in class. Um, and the clue is kind of in the name, right? Audio in refers to being able to take audio into your program. And the most obvious thing that does that is a microphone. So effectively what we're going to be talking about is using this aspect of the P5 sound library to work with the user's microphone. We're going to keep it pretty simple. There are complex things that you can do, but even simple things that use the microphone are surprisingly powerful. Just because sound input isn't super common, and because sound and making sound as a user especially is it's a pretty emotional and effective thing to ask somebody to do, either to make like loud noises or to be quiet. They're things that really cut into social norms and feelings that people have about using their voices or their environment and the sound levels in their environment. So there's a lot going on with sound. So you don't need a whole lot of tricks to make some pretty interesting work. So that's the hope anyway. So let's talk about this thing, P5 audio in. And let's begin by going over to the documentation, always the right thing to do. Sorry, let me get back to the main reference page. So P5 Sound Libraries reference page. And we're talking about audio in, which is the third one down here. And as I've been saying, get sound from an input source, typically a computer microphone. You can use other things there, but really the microphone is going to be what we're going to discuss here. So let's pop into the documentation. And right away, actually, you can see one of the features of using audio in a browser, and so I'll talk about it right now since it's there, which is that if you ever have a program that's running in your web browser that is going to use the microphone, which is what we're going to do, every browser these days requires you to give permission for that. And it's fairly obvious why, right? Like it's a huge privacy concern to enable the microphone and potentially record people. And so the browsers have this built-in thing now where as soon as you try to access the microphone, you get a little message like this. p5.js.org, that's the website, wants to use your microphone, and we can either block that or we can allow it. Now, because I want to go with the flow and I want to look at this example, for instance, clearly I'm going to allow it, but you have to then potentially be aware that when you make programs like this, users may choose not to let you use their microphone, and you have to decide whether you want to handle that situation or not. But for now, let's say allow. So here we are with the documentation, and we've got this as well. Like, geez, there's like extra levels here. Google Chrome now. This is the application wants to use my microphone. This is my operating system trying to ask, do I really want this application, Google Chrome, to use my microphone? Another layer of privacy protection. And again, you can see why. So I'm going to allow it. So let's look at, again, the documentation here. And you can already see what's going on, right? Over here, in this little tiny, I wish they weren't so tiny, but they are, this tiny little example, you can see this little ball is bouncing up and down as I talk. And if I talk a little bit louder into the microphone, hello! Sorry about that. You can see it went right up to the top. So you can tell that the position of the ball is related to the volume that I am putting into this microphone. And so we could look at this example and figure out how they're doing that, and really figure out the secret, really the thing that I want to address as well with this component of the library, which is just the simple idea of getting the volume that's going into the microphone. So we can see there's a few things that we're going to care about here. One of the things is here. As is the case with all of these P5 sound classes, we're going to want to create an object from that class. So we're going to create, in this instance, a microphone object, effectively. So the variable declared up here is called mic, or mic for microphone. And we're going to assign it a new P5 audio in object that's going to be able to process it's going to be able to process sound that comes in through the microphone, which is the default audio in device. Just like with the oscillators, funnily enough, but it means something else. We have to say start, and it's this moment where we say start that we're actually trying to activate the microphone, and that's the moment where the browser is going to ask us for permission if we haven't already granted it previously. So this is the thing where we're asking for permission by saying mic.start there. And then the only other thing that we see that's dealing with this mic variable is here, which is that we say mic.getLevel, and that is apparently giving us the volume that's going into the level, and then they're doing some kind of mathematics here to work out how to convert that level from whatever kind of number it is, and we'll talk about that in a second, into a y value for the ellipse, so that the ellipse continues to bounce up and down, boing, 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 right? Or boing, boing, exactly. So obviously there's going to be me talking louder sometimes in this video in order to make things happen. So that's the example. It really does the things that I want to do as well. So we could almost just move on from there, but let's continue reading. So the description: get audio from an input, i.e. your computer's microphone. Turn the mic on and off with start and stop. So it's good to know that we could stop microphone input as well. That's a useful thing to do. And start is the thing that turns the microphone on. When it's on, its volume can be measured with get level, which is what we're going to do. That just seems to be getting the volume, as we've gleaned from that example. And then we can do more complicated things, such as by connecting an FFT object. FFT stands for fast Fourier transform, and it's a way of analyzing sound waves. I'm not going to go into it, but it's something you can look into. It's particularly so that you can get the frequency spectrum of a sound, which can be interesting. If you want to hear the audio in, use the connect method. Importantly then, one thing that we learn about audio in is that by default you don't hear that sound playing back through your speakers because it would create a feedback loop, and we don't like that. There's another note here which is important. It uses a specific API, the Get User Media Stream API, which is not supported by certain browsers. So this is an important thing to notice about anything you're using. There are browsers don't all support exactly the same thing, and so if you're going to use the microphone like this, you would want to know for sure that it's going to be supported on the browsers that you're going to distribute it to. That's perhaps a topic for another day, how you find that out, but it's not too difficult. Access in the Chrome browser, which is what we're using, is limited to localhost, i.e. when we're running it on Atom Live Server or our local server, and HTTPS. So HTTPS is the secure form of HTTP. When we use GitHub and GitHub Pages to host our work, it's on HTTPS by default, so that will be fine. But you should be aware if you've got your own web server and it's not using HTTPS, you may have trouble with the microphone there as well. So there's a few considerations there, right? And these are things that, as developers, we need to care about. So that's the description. It told us a few useful things. But really, again, the thing we're excited about is start the microphone and get the level with get level. That's what I care about. How do we create one of these things? We create a new p5.AudioIn object. There's this extra thing we can do, which is called an error callback, but we are just going to ignore that. This is a way to more gracefully handle the situation where there are errors of some kind. And in a perfect world, we would do this, but we're just going to ignore it because it's too much to deal with right now. So, what do we have available to us? Well, we have some fields. Again, these fields, there's things in here that we might care about. Maybe the one that's the most interesting would be enabled, which will be true if the user has allowed us to use the microphone. So we could imagine checking that to make sure that they have enabled the microphone. And in fact, it's a good way to kind of respond. So for instance, if that's still false after we've tried to enable the microphone, maybe our program gets upset with the user and is disappointed in them for not enabling their microphone and being so cowardly or something, or so privacy obsessed. So we can kind of use this field or property as a way of checking what the user has done in terms of permissions, and we can respond to it in some way, depending on what our program needs to do. The list of methods, just to move on to those, again, the ones that I'm going to care about are start. That's the one that asks for permission. We need that one. We might need to stop, but I won't bother with that right now. And get level is the other major one that I want to use, because that's the one that's going to tell us what the volume level is. So that's really this is the one I care about. So this is probably the one that we're going to really take a look at. So what we want to do is we want to access the microphone and check the volume going into it. So we already know the steps that we need to do that. So let's do them. And let's write a program, like always. So we remember, I think, from the example and from all of these examples really, is that we need some kind of a variable, I'll call it mic, microphone, to store the object that's going to kind of control, in this instance, the microphone, just like we did for oscillators and everything. We should make a canvas because otherwise we won't be able to see anything. And while I'm thinking of it, let me set the background to black as well. And then in order to have the microphone do anything, I have to say mic is assigned new p5.AudioIn, which is the type of thing, parentheses. So that's calling the constructor of the AudioIn class. So that makes me a microphone accessing magical object. But we also know that I have to say mic.start in order to say, give me access to the microphone, please. And that will enable the user to decide whether or not to do so. So those are the steps there at the beginning. Make a new microphone or audio in object and start it. And then how do we display the level? Well, we know that there's this, this method called getLevel, right? So maybe let's read about that. So here's the getLevel documentation. And notice that it does not have an example, which is a bit of a shame. The main example for audio in had an example of using it, so it's not the end of the world, but it's a bit inconsistent. So getLevel will return the volume level. We can see that down here in the return. We can also actually provide a smoothing value. I guess that's to maybe avoid certain artifacts of the way that a microphone sounds. I won't bother with that, but it's something that one could play around with. The main thing I want to know is that when I use it, I get back a volume level between 0 and 1, and I want to show that on my screen. So let's do that. So in draw, let's get the level. So let level is assigned mic.getLevel. So that's my level. If I want to display it, let's begin by just displaying whatever is inside that variable. So I could do that with console.log. Actually, why don't I just do it with console.log? That's easy. So let's print out whatever's in the level variable in console.log. And let's go take a look at our project. So I'm going to need my... Whoa. I'm freaking out about that amazing sound. I honestly don't know what that was. I think that might have been an artifact from a previous run of the program. That was kind of terrifying. So close to Halloween. Never mind. We will assume that we're not haunted. So actually we can see a couple more things here, which is interesting. We can see that pop-up that I was talking about before. This is being triggered when I called mic.start, right? That's trying to ask for permission to use the microphone. We can also see that my program is running. Like, it didn't wait to get permission, it's just running. And we can see that it's printing out the level here over in the JavaScript console, and it's 0. So it doesn't have access to the microphone, so it has a volume of 0. But I'm going to allow it. Allow. And now we should have the situation. Oh, and this is, oh, great, fantastic. Well, I've run into the other problem that I wanted to run into, I suppose. And this is an interesting one. So you can see here, I've created a problem. And in particular, you can see here that there is this little circle here. And it would be red if I wasn't in a dark mode, but I am in a dark mode, so it's not red. It's a circle, and this is a recording circle. It's telling me that this tab is accessing my microphone. And this tab is accessing my microphone as well, right? Because I'm looking at the documentation, and that accesses my microphone. And it turns out that that can create problems. In particular, if you've already got a tab open, like this one, that is using your microphone, in this case from the previous example over here, you can see that it's happy, it's working, and the microphone input is showing up in the little example there. But it turns out that, generally speaking, you don't want more than one of these things open at the same time, because if they're all trying to access your microphone, then it can cause trouble. And as you can see, it's causing this one, my program, not to be able to access the microphone. So to fix that, I'm just going to close this window. I'll open the documentation again if I need it, but we're not doing a lot with the documentation anymore. And I'm going to reload this program and see if that fixes my situation. And it did not. So this is good. Well, it's not good, but it's a thing. So often with these kinds of situations, so reloading didn't work. The thing that I would do in this situation is I would actually go over to Atom, and I would go to Atom Live Server down here, and I would stop the server completely, just because it's like a hard reset. Like, did you turn off and turn on the router, right? This is the equivalent of that. And then I'll start it up again, and we'll see if that solves my problem. So there's the previous one. I'll get rid of that one. And I'll allow this one, and I'll open up my JavaScript console. Oh dear, now we're getting into some trouble. Let's try this one more time. I'm going to stop the server. I'm using keyboard commands now because I feel annoyed. That was Control-Option-Q for the record, and then start the server again. And drag it down here so we can see it, and click Allow. Look at the JavaScript console, and oh my goodness, no! I'm almost at my wit's end. I'm not really sure anymore why this level is not doing anything. What can I do? What can I do? I feel frustrated, team. I got to tell you. Why did their one work? And why did my one not work? That's what I want to know. I'm not typing anything in wrong. Oh! Okay. Now, that was perhaps also a useful, if depressing, lesson in programming, right? I'm not 100% sure why this started to work, and that's never a good thing. However, it did start to work, so I'm just going to keep this video the way it is, because I think it's useful to see me thrashing around a bit, just because, you know, this is the way that programming goes, and it's unfortunate. My guess is that, yes, restarting the server was important. I needed to make sure that all of the windows that had recording symbols on them were already closed, and then it turned out I needed to kind of remake this. It seemed like what happened is I made a small change to my code. I added that carriage return, and then when I saved, it started working. You can also see, by the way, that once I've given permission once for this page, it just works by default after that. So giving permission once stays. So users only need to give permission one time. I don't even know if that's a very good security option. I'm sure you can change it in your browser. Anyway, we can see the results here over in the console. Every frame it's printing out what the let me zoom in a bit. What the value is in. Oh, that's maybe a little aggressively large. And if I make it a bit bigger, we can see the numbers, right? So you can see that at my normal talking volume here, it's generally getting up to maybe 0.1 or so. So generally the values to me kind of trend a bit low. But if I start talking a bit closer to my microphone, hello, 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 you can see it does get up towards 1. We saw like a 0.9 in there, for example. I can just go make a loud noise into the microphone for a second, sorry. Ah, there you go, right? So I'm sorry, but this is the way the microphones work. You have to make sound. So it gets up to 0.8, 0.9 if you're being quite loud into the microphone. Regular talking volume, at least for me, is between, I don't know, 0.08 and 0.2 or something like that. This is important just because we want to get some sort of sense of what these numbers are. I'll close this now, because we were just wanting to see what the numbers looked like. So we've got a sense of where the numbers go. They are between 0 and 1. To me, it sometimes feels like just regular talking volume is like super low, and then you can, if you're just being a bit loud, then it suddenly jacks up to 0.8, 0.9, something like that. But that's our simple program, right? Where we can get the level out and print it out. So that's all good. So that's it. That's kind of all we need, because now we've got this number and the level. We can do stuff with that. So let's do some stuff with that. What should we do? So let's make a clown. No, let's not make a clown. Let's not complicate things. Let's make a circle. And is there even any need to do this? No, I don't know what I'm doing right now. I'm sorry. Let's just draw a circle. And what we'll do is we'll base the circle's size on the level. So let's do that with a map, right? So let's make a size variable. And this is just another way to visualize it, right? But let's map the level. So that's the number inside the level. We know that's a number between 0 and 1, right? So that's the range it comes from. And what do I map it to? I'll map it to be between 0 and the width of the canvas. So if I make the maximum possible amount of noise, then my circle size is going to be the width of the canvas. And if I'm completely silent, then my circle's size is going to be 0 pixels, and I won't be able to see it. So this will tell us some other things, right? Because looking at numbers, it gives you the hard data, but understanding the behavior of these numbers, sometimes it's better if you have a visual representation. So with that information set up, let's draw a very exciting circle. So let's set a fill. I like red in these circumstances, no stroke. And then we'll draw an ellipse. We'll draw it in the center of the canvas. And we'll draw it with the size that we just calculated. Okay? So it's responding to the microphone because we use mic.getLevel. That goes into the level. And then we map that level result to be between 0 and the width. That's going to be the size of our circle, and then we draw our circle with that variable. So what do we see? So if I'm completely silent, like now, I'm in a pretty quiet room, so the circle dwindles away to nothing. So I think I more or less seem to have achieved 0 level. As I talk normally, you can see the circle stays fairly small. You can see how it kind of gets big on certain plosives, for example, or when I put emphasis on a specific word or something. But you can kind of get a more of a sense of the way that it's behaving, right? And if I talk again into the microphone a bit louder, la 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 la, ah, then you can get some sense of how big the circle can get. Again, same thing, just that we can kind of see it a little bit better. You can even get ideas for things that you could do with this, right? Like if you were making some kind of simulation or game where you're trying to avoid things, and if those things responded to the volume coming into your microphone, then you might want to keep super quiet so that you could avoid them. But then if you cough or something, then they suddenly get really big and they hit you or something, right? So there's ideas everywhere. That's my point. But just to make something a little less abstract than just a circle that changes size, let's do something Halloweenish and make a scared ghost. And I'm going to do a really simple version of this. I've got a slightly more complex version of this in the notes for this video. But what I want is, I want a ghost that is afraid of me. Well, it's afraid of loud noises. So let's trim this back again and get our basic program. So this is the program that gets the level. And let's create our clown ghost. So I'm going to say ghost, looks like this. What am I going to need to know about the ghost? It's going to need a position. It's going to need, so I should say, what do I want this to do? Well, what I think I want this to do is I want it to sort of sit in the middle of the screen. Maybe it can tremble a bit to symbolize that it's afraid of me. And when I make a loud enough sound, I want it to run away off the screen, like it's terrified. So what do I need to do that? It needs a position, because I need to know where to display it. It needs a velocity, which should start out at 0, because it's not going to be moving. Maybe it will tremble. And it needs an image, which is undefined to start with. Does it need anything else? If it needs something else, we'll come back to it. Because it's got an image, we're going to need to preload the image. So we'll say ghost.image is assigned load image, and then we'll just load the de facto clown image, like that. I guess, no, this is fine. Okay. So we do all of these things. I guess I said I wanted the ghost to be in the center of the canvas. So I'm going to set its X and Y here in setup. Remember, I can't use the width and height variables that come in the package with P5 until I'm inside the setup function or the draw function or functions that are called from them, because width and height don't exist until then. So that'll do that, and then let's at least get our ghost to display itself. So we'll use image mode center, and we will draw an image, which is going to be ghost.image at ghost.x and ghost.y. Let's at least get that working. There it is. Now, if it's a ghost, it should be a bit transparent, and we can make images transparent with the tint function. Kind of works a bit like fill, except that if I set the color of the tint to white, which is 255, that won't change its color, but then I can give it like an opacity of, let's say, 0.2, something like that. Oh, wait. This second number, the alpha value here, is between 0 and 255. So 0.2 is a very, very, very transparent ghost. Let's make it 50 and see what that looks like. There, perfect. So there's my ghost sitting in the center of the screen. Now I said I wanted it to tremble. I think I do want it to tremble. So before I display it, I am going to just add a tiny little random amount to it. Just between -1 and +1. Maybe I'll make it even smaller depending on what this looks like. And this is just to make it look afraid. Yeah, it looks scared. So it's trembling, it's worried about what's going to happen, it's trying to smile through it, but really it's terrified. Okay, so we've got most of what we need now. What we finally want is to be able to scare the ghost. And we're going to scare it by making a loud sound. So we know that we've got this level here, and we know that that level is a number between 0 and 1. So how do we check if this level is loud enough to scare a ghost, and what do we do when we scare it? Well, part one is, how do we check if the ghost is scared? Well, we need an if statement, right? If the level is greater than what? What's a scary level of a sound? Let's say I don't want it to be too loud because I don't want to scream into the microphone. Let's say greater than 0.6, because we know that my regular speaking volume doesn't get that high, but then if I shouted, I think I would get it that high. So if the level is greater than 0.6, and obviously there's like hard-coded numbers here that we should be moving into variables and properties of objects, but I'm just making an example, so I will cut myself some slack. So if the level is greater than 0.6, that's considered scary. So what should I do? I should make the ghost move off the screen rapidly. And how do I do that? I could give it a velocity, ghost.vx. I'm going to say exit stage right. So what would be considered fast? Let's make it move at 20 pixels per frame when it's afraid. So when it gets a fright, I'm going to set its velocity to 20 so that it moves rapidly to the right. It'll keep trembling because these are still in draw. But there's one other thing I need to do. Hopefully you noticed it. I almost didn't. Which is that if I'm going to use the velocity, then I have to make sure that I change the ghost's position according to its velocity, just like always. And even though I know I'm not changing its y velocity, it's just polite to still do both. So this is move the ghost. This is check if the ghost is scared. This is exit stage right. Get volume into microphone. This is trembling. And this is draw the ghost, display the ghost. Okay, so those are all of the components, right? Trembling. So good grief. It trembles by moving a bit randomly its x and y. Then we get the volume into the microphone. We check if it's high enough, and if it's high enough, the ghost is scared, so we set its Vx to 20. And we always make sure that we change the ghost's position according to its velocity. In the beginning, its velocity is 0, right? So it still won't move. And then we display the ghost. So what does this end up looking like? There it is. It's trembling. It's trembling. This will be embarrassing if it doesn't work. Let me give it a fright. 1, 2, 3. Boo! That shouldn't have been so satisfying, but it really was. I won't do it again. I'll leave it to you to scare your own ghosts. But how satisfying is that? There's that visceral connection between me and this poor scared ghost. I'm feeling slightly guilty that I scared it away. But you know, I made a loud sound in physical reality here in my office. I made a boo sound, a classic boo sound, and the ghost that is inside my computer in my web browser was frightened and ran away. I don't know what more you could possibly want than that. That is deeply, deeply satisfying, I think. And that's really, you know, that's kind of the basic power of the microphone, right? Even if we're not doing voice recognition or sophisticated, you know, fast Fourier transforms and frequency analysis, just the volume going into a microphone is incredibly expressive. And just as much as being loud is expressive, being quiet is expressive, maintaining a specific volume consistently over time is an expressive thing as well, right? Like that's difficult to do. So there are just so many interesting things I think that you can do based on this one input variable that we can get from the microphone. So hopefully that leads to some excitement on your part. I know that I am, again, unreasonably excited about scaring that ghost off the screen. And I'll see you in the next video. Bye.